primary screens, living in the grand spatial dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvels standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive.
Hello contributors, how are you? Today we have the presentation day of the projects that the GSoC contributors have developed, and when we say GSoC, it seems to be GSoC, but it's not GSoC, but it's GSoC, Gemini Summer of Code. I have with me mentor Siddharth Murgil. Hi Siddharth.
Yeah, hi Andrew, and hi everyone. How are you doing? I hope everyone is doing good.
We are good. And first of all, I have to thank you a lot because you've been the mentor that has pushed for this program. You supported the idea since the very beginning, and you've been helping the students to achieve their goals. We have, I think, 11 contributors doing that finally.
Yeah, we have 11 contributors, and all are active.
Okay, that's the most important question, that they are active, because let's comment first. Let's explain a little bit what is Gemini Summer of Code. GSoC, but with GE. Explain, Siddharth, what is GSoC?
So Gemini Summer of Code is another open source program. So it is exclusive to Liquid Galaxy, our organization only. So the whole main goal around the Gemini Summer of Code is that many contributors and many talented contributors came for GSoC, but they were not able to achieve GSoC because of limited seats. But they still are talented, and we think that they need some other program, and that's why we started this program. And this is more open and more collaborative program than Google Summer of Code. So, and I think we have achieved this thing, and all are very active on Discord and sending all sort of contribution and all.
Exactly, I believe that it was a great idea, and it's been nice during the summer. I think we started a few more contributors, not much, maybe 15 or something like this, but those 11 has been working, and at this moment they have sent us several APKs to test. They have sent us several videos for presentations, for midterm, for the. I don't want to say demo day because it's to don't rest importance to GSoC. We are calling it presentation day, where these contributors are gonna present their projects. That has been treated exactly the same that GSoC, but of course with less resources, because we are focused on GSoC during the summer. But I will say that you've been doing a great job.
Gemini Summer of Code is also more free than Google Summer of Code. Like all repos are public to each contributors. They can see others' code and comment on each other code also. So
yeah, also,
I will say.
And also, I think the most important thing is that it's AI based. Focus on AI. All the GSoC contributors have AI in whatever level of need they have, with IPS externs or whatever. But in Gemini Summer of Code, we ask specifically to the contributors to work with Google APIs for AI, using Gemini, Gemma, or whatever. And this is the name, Gemini Summer of Code. Okay, so how's been your experience, Siddharth?
My experience was very good and exciting. Like all those discussion meets I had with all Gemini Summer of contributor, it was very exciting. like it was very collaborative with, like multiple other contributors were helping out other contributors. Like I still remember Tanishq, I think, suggested some AI feature to Amit, so it was very good experience.
Yeah, and it seems a little bit strange when you said before that this is different from GSoC because it's more open, and that's true, because for several historical reasons, GSoC is a one-person project. And I usually say that it's a two-person project: the contributor and their mentor. And some teams are more than a mentor, but it's contributor and mentor. But they are not usually sharing code or sharing things during the development of their projects, because even being open source, sometimes happen very, I would say, not very good actions. Like they copy in a bad way, because it's open source. You can copy. You have to copy, but not in the way they did. So we usually are a little bit more close during the development of the code. So Gemini SOC has been developed in a more open way, and that's nice. And also, I believe that for these contributors is going to be interesting, because in the future they will be near to us, not Shekar?
Yeah, like they already have idea how Liquid Galaxy is working, how to connect with LG, how to visualize data. So like they will be like very better in next year or like upcoming year.
Exactly. And me as administrator, next to Claudia and Josh, I wanted again to say you thank you. And I think that it's been a great idea. Also, I have to give you two thanks, because you've been doing also mentorship of other GSoC, Google Summer of Code projects. Which one?
Eco-Grid Intelligence.
Bhumi Shiva. Good project. So we will continue doing that Gemini SOC for the summers, because it's Summer of Code too. But the point is that with this idea, we want to maintain the contributing activity, the community activities during the year, and start better for next year GSoC. So again, thank you, Siddhar. Thank you to all the contributors that has collaborated with us on this project. And now we are going to the not demo day, demonstration day, presentation day, you name it. So take care. Bye bye.
Yeah, thanks. Bye.
Hello everyone, my name is Andrew Pratap Singh Yadav and I am a third year AI student from Symbiosis Institute of Technology, India. For the past 4 months, I have been working on Liquid Galaxy Arkanoid game, which was for Gemini Summer of Code 2026 with Liquid Galaxy. My mentor is Siddharth sir, and also I appreciate Andrew sir for his guidance. What got me into Liquid Galaxy is the panoramic wall and how multiple screens work, and how the SSH connection networking works. Many screens and one picture. I wanted a game that uses the whole wall and like not one monitor. So I chose Arkanoid because almost everyone has played a Brick Breaker game in their childhood, and I thought the same game could be a multiplayer game as well, with some commentary and Liquid Galaxy walls and multiple screens. So here the game is, phones are the paddles, phone is the only controller, and the walls is a board where you can play with your friends, and the screens can run on the Chromium browser. Let me deep dive into the code, and let's share it. Let's start with the README first. I mean, the README is the most important thing in any project, right? So the game runs on 8130 game port, and earlier I used, like, the mistake I did was that I used the newly built node. But since we know that the Liquid Galaxy Lidar Lab and other machines use actually the older version, so this game now I made the version compatible. It uses node 16, 18, 20, and also port 8130. So how it is built? So it's basically the three pieces. Where the phone is not the wall, the phone is only just the controller. You just put on, move the slider, and the ball and the game would be visible on your Chromium browser. So here, as you can see, phone AI Arkanoid LG is a Flutter paddle, and the connection screen, which I'll show you later, is there, and socket.io. from which it runs, and where LG1 is like the middlemost screen, or the LG1 is the master, whereas the other screens are just slaves. And it's also the user input game, which like if you have like 5 screens, so you can just put on 5 screens and it would be displayed on 5 screens. And then chromium on each frame, and which is one left, one right, and phaser count. So how the match runs, like this is an important concept, and how much a match runs should be known. So first, what we do is that first we clone the repo, clone my GitHub repo, and which I've made public now. And we'll clone the repo on our main machine, which is Liquid Galaxy, and we then install it using the bash install command I have already given in the my readme file. And then we launch it on our rig, so that QR code interface comes in. I'll show up the demo next, and you can just see it. And then the Chromium browser opens every screen. The centermost screen will show the QR code, the leftmost screen will show the Gemini SOC logo, and also the Liquid Galaxy logo. And then your phone, suppose this is my phone and I will actually connect it, scan it, and I can connect it, or I can just type in the code as well. So scan code or QR, or type the code, and then comes the first player. Whoever the first player is, suppose this person is the first player, I will just scan the QR, and if the person has scanned it, the very first person would have an option to choose team members, and then the duration of game and everything. So now what comes next is that first player then can wait in lobby, or can start, like suppose it can decide the match duration as well. So it sets the time, players 1 to 5, and also the speed of the game and the level as well. I'll quickly show it in the demo phase. And then the ball rings, which was 3, 2, 1, and the whistle beep comes in, and the game gets actually start. So then also you get an exceptional commentary from Gemini if you put in your Gemini key, API key, in the terminal, which will be coming when you install the bash using the bash command. If you don't put your Gemini API key, we have a fallback, which is a TTS, and we already have a set of instructions to which we have given to our game. So whenever some event happens, it's event-driven commentary if your Gemini isn't there. So if you put Gemini key, then you will get an exceptional commentary. If you don't, then also it works. And if you put your Gemini key, we have added a fallback of 10 models. I'll quickly show up the most interesting part of the game, which I actually faced difficulty in. And this is the thing I felt like it's the most important. Like, this is the splash screen, and I always wanted a splash screen to be minimalistic and always the normal. And so I can see, as you can see, the animation controller and the duration. Duration has to be in milliseconds, and this has to be 2200. But the most important and the thing I actually faced difficulty in was the SSH service Dart. And if I talk about SSH service Dart, it's the actual SSH connection out there. I actually took and help with anti-gravity and AI agents across, so I don't face any difficulty. I also took help from the Pacman code repository, where you just can get a GitHub repo and code as well. And if I talk about game service.dart, this is the most important thing, and I actually faced a lot of difficulties thanks to mentor Andrew and mentor Siddharth sir, because they helped me during the pre-phase Google Meets when we had, and I told them that I have doubts, and my ball is not going across the wall, and my lives is not coming, and many more, because this is actually the physics part, and I actually hated physics during my school time. But thanks to this game, I have started learning physics because of this game. I actually took help from AI, yeah, but I actually know where my code is and how it's running, because physics is very important part of a game if you're building a game, and not just a game but also a multiplayer game, I'd say. And what it does is, I'll just quickly explain you the session token, which is a temporary token. And this robot state timer, what it does is, it takes on the robot. You get a robot in below the screen, and that robot, when to move, in which latitude, in which longitude, is all controlled by this physics. And then you connect, and then also the latency thing is very important, because my robot was actually in at this place, but it moved to this place, and it took a lot of time, and the lag was happening because of latency. And now let's come on to the some widgets which I have used. Like these are some widgets, and also thanks to Siddharth sir, because he explained me that you should add QR code instead of just code. So I just added a QR code, and thanks to I'll say on Stack Overflow, because I took half of the code of this from Stack Overflow, and then and exceptional code was there. And then let me just show up the connecting screen which I was talking about. The connecting screen, I didn't took much time in this, because we already had built 2 earlier projects before in GSoC 2026 when I was actually doing the prerequisite task, and also when we had to do it for Gemini SOC as well. And the connecting screen code is actually there in a lot of Liquid GSoC projects, so it was of good use. And then you can just put on some your error handling trials, catch block. So whenever you make a production ready game and not just a buggy game. And then let's just see if we can see the screens. This is the setting screen, and setting screen is also the similar thing where you use SSH if your SSH is connected, if your SSH is good enough, and it's the logic hits, and then it is connected. And then you use a synchronize function and await function, so that there's always a security in this, and it's not and yeah. So this is a ANV example. Like suppose you the port is 8130, and suppose you get an option for Gemini API key. You just put on your Gemini API key here, and then it will be running. I can also show you the scripts. Like these are the scripts that you will have actually running, and these are some NV nodes, and I will these are the scripts that you will get from the README. And this is it. I'll just quickly show up the demo now. Okay guys, so here's the quick demo. Like this is the middle screen which will be the master, and here's the QR code, and also the session code will be visible. So player gets 2 options, and here's the app. And let me just start it again. Here's the app. So it starts. We can just enter the code manually. We can also do from the reconnection. We can also do from the scan QR code. As I have only one Android phone, and so I am playing one emulator which is on Chrome browser, and these are also Chrome browsers. Okay, so let's start. Let me just scan it. Okay, so it's scanned, and I will be putting my display name, which is Anirudh. Okay, cool. And then ready. As you can see, I have joined, and here it shows the ready. Currently the screen is small, so that's why it's showing only one. And here also it shows Anirudh ready, and slot 2 is open. So now let me join from here. Okay, so I will put on the code here, which is Q9SB, and let them see. As you can see, we have joined the match. I have joined as a player 2, and the first player which he gets the option to choose the speed of the match or the details of the match. So let me choose the players 2, and ball speed let me choose as fast or fast, and match duration 3 minutes. I can also QR invite people, and let's start the match first. So okay, so it's starting.
3, 2, Anirudh took first
Now
from player.
I lost the ball because it's very getting tough for me, and
Anirudh lost the
now
line.
it's winning.
Cover the
Now
floor. Player took first from Anirudh.
okay, it's going. It's very difficult for me to play, but you get the things, like it's quite a demo. And here you can see the lives and the live score. And now any player can play. It can be from 5 players, it can be from 3 players. As the screen is short, it might see like this. I lost the life, and here also commentary you can open and enable. And here in emulator it will be a female voice. It is coming from Gemini, and I have lost the voice, so that's why I'm not able to control. And yeah, and from this, and now I can do it. And as you can see, I have lost the life, and here only 1 life is there. In optional you can get it to 3. Here you can see the commentary, and let me lose my life. Now you see you win, and here comes the second place. Like I've got the second place, the score, and and here comes the scorecard. So this is the whole game, and like I know there might be some improvements and there might be some bugs in it, but I feel like future people can also and mentors can also improve it and help me improve it. I have some more days left, so I'll be doing it more efficiently. And since this was my first game development journey, I feel this is a good demo for me, and but I feel I can improve it more further, and you can drop in some comments to show that what needs to be improved. This was my game, Arkanoid game, Arkanoid A for Gemini SOC, and thank you Liquid Galaxy, thank you to all the mentors, Andrew sir and Siddharth sir for mentoring and giving me guidance, and I hope to look to see this product in Go Store, and I feel like some bugs are still there. I think many improvements can be made, and if you talk about user logic or if you talk about game flow, a lot of fixes can be done actually, and I hope to hear back from mentors soon. And even if the contributors, any wannabe contributor next year wants to have some changes in it, let's do this. Let's make this one of the best game ever in this organization. And also thank you because of because of your GitHub repository, which was for screen recording. It really helped me to screen record, because I was actually gonna use OBS Studio, but it didn't work much. And so thank you to you as well, sir. Thank you, Liquid YC. I hope to see my game on Go Store. Thank you.
My name is Ankit Yadav. I am a computer science AIML student, third year student at Gurugram, India. My Liquid Galaxy project is a climate change storyteller. That is basically, as the name suggests, it shows the climate change. It tells the projection of the climate change, and it also shows it uses the like NOAA basic different data from the climate sites where the data for the climate is available, and uses the ARPCC report for the projection that how the climate will be in the future. So let's dive into it.
So the architecture which I use is a service locator with locator pattern with the features. So you can see assets have some use and all. The core contains the DI container, the storage and the theme, and the routers of the app. And the features have all the features, core features basically. The climate data, where the data part is there. And Explore have all the screens, and LG connection is controlling the connection and the KML processing on them. So and narrator. So this is our main. So main is the point where our app starts. Now if I take you to the, so this is the basically data part where our data from the IPCC and the generation from that data, the KML generation from that data takes place. Now the main part is the slider. So here you can see that this is basically for the connection, direct connect, and this is for basically for the current region, at what region the slider is at. This is initial year. This is the minimum and maximum range, like the range in which the timeline is. This is basically a KML throttle. This is on year change and on year change, and so these are like callback during the drag. And now the problem is might like when the user slides, the user might have slided to the other timeline, and the KML of the particular part is being loaded, like it is not yet loaded. So for that we have used like this one, you can see here. This checks basically are we matching to the requirement still. If the slider has gone, then this will drop the KML which is being loaded and try to render the KML which is at which the user is right now at the drag. So this is basically the slider part. So now let's see the demo, like Himalaya.
The Himalayas in 1900 stood as the third pole of the Earth, a colossal sanctuary of ice, snow, and towering peaks spanning thousands of kilometers across Asia. Over 40,000 square kilometers of ancient glaciers nestled in the high-altitude valleys.
Narration goes on as previous, and you can see the slider is working properly. Little bit lagging on my system only. You can see the number of uh, triangles are like here representing the snow part. They are decreasing as we are reaching to the future of the family. And we can do the 3D orbit also. Let's see the Pacific.
By 2100, sea level rise of up to 1 full meter will present an existential threat to low-lying Pacific atoll nations such as Kiribati, Tuvalu, and the Marshall Islands. Large portions of inhabited.
So currently you can see that there are only two aquifers representing that the as a KML that shows that the aquifers are decreasing. So if I slide the timeline, the number of aquifers at the Pacific will increase. Like yeah, they are increasing.
That was my demo. So I would like to thank Liquid Galaxy for this opportunity of Gemini Summer of Code. Thank you.
Hello everyone, I'm Samatma Bharadwaj, a third year undergrad student currently pursuing my BTech in Computer Science and Engineering at PS University in Bangalore, India. Today I'm going to be demonstrating my application which I worked during the program of Gemini Summer of Code, and I developed an Earth system, AI-assisted Earth system and climatic explorer, immersive visualization of global climatic processes using Liquid Galaxy. The motivation behind this was very simple. How do large-scale processes such as ocean currents, atmospheric circulation, and climate oscillations affect the weather we experience in our day-to-day lives? So let us start by connecting to the Liquid Galaxy Rig. This is the splash screen and the onboarding screen. I have the details entered here. So let me connect to the Liquid Galaxy Rig. So on connecting to the Liquid Galaxy Rig, a logo is sent to the top left corner of the leftmost screen. So we can see the logo here. Let us start exploring our application. Firstly, let us visualize the Indian monsoon effect. As soon as the Indian monsoon visualization starts, you can also see the tour which takes place. And this is the AI details card, which has the AI generated insight and the and then the weather effect and then the average effect caused by it, and then this is the AI generated summary of it. I also have the TTS enabled, which narrates the effect summary of the effect. Let me stop the tour. Now let us visualize the Kuroshio current. So this is the Kuroshio current KML which we are sending to the Liquid Galaxy Rig. So it flies to the Kuroshio current region, and then you can see the Kuroshio current KML here, and then the details card depicting about the Kuroshio current, which tells about the climate phenomenon, and this depicts the gradient color of the arrows depict the temperature of the ocean current, with red being warmer and yellow being lighter. And then this is the AI generated summary about the Kuroshio current. I'll exit the tour. Now let us visualize a line effect. So yeah, we can see the tour started, and we can see the arrows here, and then these symbols denote the regions which experience drought because of El Nino effect, and similarly we have regions which experience heavy rainfall due to the El Nino effect. Now let us see, we can also visualize other effects like Gulf Stream, La Nina, etc. And then we also have the map sync, which is bi-directional. So I can control the Liquid Galaxy Rig I can move the Liquid Galaxy Rig by moving the maps in my mobile application. And then this is the chatbot, which uses the same Gemini API key which you enter in the settings. And you also can see the regions experiencing heavy rainfall, which is denoted by the flood symbol. And this is the city explorer. So on entering a city, for instance, let me enter Paris. So it should navigate to the city and start orbiting, while also telling about the weather conditions in that particular city. So we have the Eiffel Tower, which comes up, and then This is a page where different Liquid Galaxy services can be done, which is shutdown, reboot, clear KML, show logo, orbit, refresh, and exit to, which also shows the rig availability status. And then this is a settings page where the settings of the Liquid Galaxy rig can be configured, and then this is the place where you enter the Gemini API key, and this is the, you can also switch between light mode and dark mode and colorblind mode, and you can also have select different voices which you need for the narration. So basically this is my application and the demo of the app. Now let us go to the code. I have the diagram here which tells about the data generation pipeline. The data is fetched from ERA5, which is the data source, and so this is the processing of the data source and generating the trajectory, which gives a .json file containing different monsoon paths, which is then referred by the arrow generator code, and then it uses the trajectory to denote the ribbon boundaries. And I haven't used a line string, and each of these are each of these are small polygons which you can see here with a gradient color. The color is generated by a function which is interpolate color. As the temperature increases, the color gradient to increases, and then I added the fixed icon here depicting different effects. So and finally it generates the Indian monsoon.kml. So the generated assets are loaded to the Liquid Galaxy rig, which is Indian monsoon KML and Indian monsoon 2. Last but not the least, I would like to thank the Liquid Galaxy team, mentor Andrew, mentor Siddharth, for providing feedback and for helping me fix issues, improve my application, and make the overall user experience better. I learned a lot during this experience, and hopefully the learnings which I learned would prove to be valuable for me. Thank you.
Hello everyone, my name is Dipen Nandwani, and the topic of my project is Flutter Air Mashup Intelligence. In this project, we will be projecting flight data on the Liquid Galaxy rig using our Android application, which is built in Flutter. We will connect our Android application to the Liquid Galaxy rig using SSH connections, and we will show the flights on Google Earth using KMLs and Flight, with which we will pan to India, Spain, and with this we can show multiple flights on Google Earth. We have also deployed the XGBoost model, which is a machine learning model. We have trained the data using opensky.org website. The data is being trained which is there in the CSV files, and the model is finally put up on a web service. With the help of that model, we will be able to predict the flight locations based on the historical past data as well as the live data which has been taken from the OpenSky API. And I would like to thank our mentor Andrew as well as mentor Siddharth, who have helped us along the internship program Gemini Summer of Code. In this, they have conducted multiple discussions in which they have solved various doubts and other problems that we have faced during the program, and I would like to thank them for the same. So this is my application, Air Mashup Intelligence, which is connected to the Liquid Galaxy rig via SSH connection. As I click on the send logo button, the logo is sent on the leftmost screen. Then we move to the home screen. On the home screen, as you can see, when we click on Visualize Aircrafts in India button, the camera will now pan to India, and it will now show us the aircrafts which are there in India. As you can see, the aircrafts which are in India are shown over here. We can also clear the visualization and move to visualize aircrafts in Spain. When we move to Spain, the aircrafts which are there in Spain will be shown to us on the Liquid Galaxy rig. So here, as you can see, the aircrafts on Spain are finally visible to us. We can clear these aircrafts and we can move to flight routes location, and as we click on flight routes over here, as you can see, the flight routes The aircrafts which are nearby are finally visible over here. The aircrafts which are nearby are shown by yellow lines. We can clear the aircraft connections from here and finally move to the AI prediction screen. When we click on the predict future location of Indian aircrafts, it will start showing us the aircrafts which future predicted location on the liquid galaxy rig on Google Earth. As you can see, the predicted location of the aircraft is visible as the red aircraft, and the current location is shown via the OpenSky API with the help of the blue aircraft. So this is the code for my project. As you can see, this is the AI model folder where our AI model XGBoost is deployed. It predicts the aircraft locations with the help of latitudes and longitudes, which are taken live from the OpenSky API, and the XGBoost model, which is trained with the data which is there in these CSV files. As you can see, this data has also been taken from the opensky.org website. After this training data, we have trained the model XGBoost and we have put it up on a web service so that it works for our application. As you can see, these are the code for the screens. This is the AI prediction .dart file, and these are the flight routes, home screen, and settings screen code. After that, we have the services code. As you can see, we have the AI prediction service, which gives us the AI prediction using the XGBoost model for our application. Then we have the connections.dart, where we have most of our KML and fly2 connections. Then we have constants, where we have values stored, and then we have globals.dart, which is where we are having our SSH client, which is initialized. And then we have KML service, the OpenSky service, where we take data from OpenSky API, the root service, and also the TTS service. And this is finally the main.dart file.
Hi everyone, I'm Karthik, and this is my final demo video for Gemini Summer of Code. My project was RPG game for Liquid Galaxy. So let's get started. So this is the whole code base for my project. Let me show you the public folder. So inside the public folder, I have all my assets, like all the PNGs. Let me show you. So these are the assets that I used. There's also one trace one. So these are all the basically all the assets. I also have my maps. I use like these whole tile set in tiled. So I created the whole map in tiled. So then I exported that map in JSON data. So I've kept all my maps inside the public folder as well. So let's close the public folder for now, and let's take a look at the backend of the project. So our backend is basically a node server. So it establishes a socket.io server that is running on port number 8128. Why I chose port number 8128 is because since LG is basically running on a local shared networks with master and slaves, so the port number 8128 was like essentially best choice for like local shared networks. So I've set up this socket.io server. So unlike other backend server, it's not handling any physics. Like in my project, I haven't like made all the physics from the scratch. It is being handled by library, matter.js library. So it handles all the physics. So our backend is very lightweight. Our backend only listens for like client calls and other things. For example, it hears for the player coordinates. It hears for the particle system, and it hears for map transitions and a bunch of more things. So this is basically the file that handles all the master and slave architecture. It keeps like it takes the player coordinates and it gives to the slaves so that they are moving in the sync. Let's take a look at asset.keys files, asset.keys.ts. So as I showed you that I have all my assets in the public folder. So this so the assets are basically constant in our game that never changes throughout the game. So I've made a constants folder for that to keep all the assets in one place. So I'm taking the assets from public folders and I'm basically putting it in the assets, like I'm rendering inside this .ts file. So I have my player I have my player PNG in this. Let me show you just a second. Yeah, so basically this is our player. It's in black. Yeah, so this is the PNGs that I'm using. This is the main character that you're going to be playing. I'm basically rendering inside this assets.ts. So I have my player, I have my enemies, I have auto splash. So basically all the assets that I'm using is being loaded in this exact file. So you can see average, additional tile set for spawn, and maps and all the UI assets is also being loaded in this assets.ts file. So basically everything is being rendered in this asset.ts file. So let's take a look at the game.ts. Right, so this is basically the main file for the entire project. It handles everything. So the technology that I'm using is basically a JavaScript. I'm using phaser library inside JavaScript, so it is natively used for developing games, web games using JavaScript. Inside phaser, we get built-in physics engine that is matter.js. So I'm using that matter.js to help me with all the physics like collision boxes and attacks and all of the other things like moving, WSD and all that shit. So I'm using this engine basically for that. Let's take a look at our entities. So I created a separate folder for the entities. We basically have right now we basically have 3 entities. First one is player, the second one is NPC, and the third one is enemies. So these 3 entities have somewhat similar properties. For example, each entity has a collision box. It has a certain amount of HP, and for NPC they don't have any HP, and for NPC they don't even have any interactive things. You cannot attack any NPC in the game. So yes, there are somewhat differences, but the overall layout, the entities are same. You can see one of the functions that I created was the mana regeneration. So what you'll see in the game is I've added a health bar that is obviously essential for any game, but I've also added a stamina bar. So basically whenever you attack an enemy or perform any attack like using space, it eats away a small portion of your stamina. So once the stamina is completely gone, you will not be able to attack anymore. So you need to give it a little bit time for the stamina to regenerate and fill the entire round. Then you can attack again. The way I'm handling animations is as I showed you that okay, so let's just take this warrior is black, but in the game it is blue. I have a separate so basically what I'm doing is I'm sectioning this images one by one so that it and looping it, so it creates an animation. So right now it is the idle one. I also have attack one. So this is the basically forward slash, since it's coming from upwards, so it's upward slash, and this one is coming from downwards, so it's downward slash, and there's also another one, so it's guard. So in this state you take no damage, like every damage is logged. So that is this, and we also have a run. It is only in one direction, but I created a bi-directional animation. What I did is I just reversed this image on the axis of 0. So right now it's running in right, but when you flip the image, it's going to be running on the left. So that's how I used the single image to create a bi-directional animation. Let's take a look. Okay, so let's take a look at our scenes. So inside scenes folder we have all our scenes. So scenes are basically whenever you load the game, the first thing that you see is a main menu screen. So this is the main menu scene. What you'll see is so when you open the screen, you'll see a background with the game name. It's RPG. So with that, you'll also see here you'll see that Yeah, title text. So you'll see a title that is RPG game, and below that title you'll see a start button that is basically what I'm using for the buttons is just a rectangle buttons with wide borders, and inside I've placed a text that is start. So what it does, it creates an illusion of a button, but it is just a rectangular object on the screen. It is lightweight, that's why I used it, and start button. We also have a settings button. So this is our settings button. You'll see only two buttons on the main menu. Then whenever you click start button, it is going to take you to the game.ts. That is where all the game loop is happening. When you pause, on the UI, you'll see settings. You can pause using this key. So whenever you pause, you're going to be on this pause menu scene. So what it does, it pauses all the animation and background things. And all of this transitioning between scenes is handled by managers. So I've created a managers folder. It basically handles all the events and inventory manager and map manager. So the transition of the scenes, like main menu to game to pause menu and to death, there is also death screen in the game. So all of the transitioning between these scenes is handled by our event manager. So all of the event that is being happening in the game is handled by the event manager. I also have a map manager. So as I said that I have basically multiple maps in the game. So there is a transition phase between maps. So whenever you travel between maps, that transition between maps is being handled by this map manager. This. So let's look at this. The particle manager. What I've done is, instead of using PNGs like this for blood and interactive particles, what I've done is I've just added a CSS file that creates small circles, red circles, that creates an illusion of blood whenever you attack the enemy. So that effects. Yeah. So these are basically all the effects in the game. I'm using some of the effects from the PNG, for example, spawn dust. So yeah, so whenever you start the game, you'll see that the main character is spawning out of this dust kind of thing. So this again, I'm playing this PNG part by part, like this part in a loop, so that it creates spawn animation. We also have a water splash animation that whenever the character goes inside a water body, it drowns and it's basically a splash. So it creates a splash animation. There's also a spawn dust. So yeah, this icon, this is for code icon. So whenever you open your inventory, let me show you. We also have an inventory manager. Yes. So this inventory manager is basically what it does is I've added an inventory system in the game. The inventory can store up to 16 different items, although there are only gold coins right now that you can collect by killing enemies. So it will update how much gold coins and items you are carrying in the inventory. So this is all the systems that I've added. So this is it. This was my project. I hope you guys will like the game that I developed during Gemini Summer of Code. Thank you very much.
So hi everyone, I'm Shrey Singh. I'm a computer science student at Army Institute of Technology, Pune. This is my final GSoC 2026 demo for the Indian Urban Heat Island Visualizer, a Flutter app that brings India's climate crisis to life on Liquid Galaxy screens powered by real data and Gemini AI. So urban heat islands make Indian city cores several degrees hotter than their rural surroundings, a direct result of concrete replacing green cover. The data to visualize this exists, but nobody has brought it to platform like Liquid Galaxy with real climate data and AI narration behind it. That's what this project set out to solve. So the app is built in Flutter with provider for state management. It connects to Liquid Galaxy over SSH using Dart SSH2, pulls live and historical temperature data from OpenMeteor and uses Gemini for narration and mitigation reasoning. Everything is modular. Services for weather geocoding, KML generation, SSH, TTS, and Gemini, all orchestrated through a single city provider. So on the first launch, users see a quick onboarding screen. So here is the home page. The settings screen lets anyone configure their Liquid Galaxy connection, host, port, username, password, screen count, and test the connection live. No code changes are required. So here you can see the success toaster has popped out. Now let's move to the core demo. I will search for Delhi. So the app GeoCodes fetches its real current temperature and a rural reference point, computes the actual heat delta and pushes a KML heat map to Liquid Galaxy. You can see the camera flying to Delhi and the concentric heat zones rendering across all three screens, sized dynamically based on real data, not hard-coded values.
Welcome to New Delhi, where summer temperatures have shifted from an average of 32.5 degrees Celsius in 1990 to 29.5 degrees Celsius today. Yet, this change hides a harsh reality. The city's concrete core
So
remains up to
Gemini
6 degrees
narrates
Celsius
Delhi's
hotter
story
than its rural
using that
surroundings
live data
because
as
of trapped
context,
heat from
genuinely
sprawling asphalt and lack
different
of green
every time
canopy.
depending on current
For millions of
conditions.
street vendors and outdoor laborers,
Now, in this narration, there is a time travel feature also. The app pulls historical summer temperatures, for example, comparing 1990 to today, and Gemini waves that into the narrative. Instead of a static snapshot, you get a real story about how this city's heat has changed over decades. Now, this is the feature I'm most proud of. Tapping Simulate Migration calls Gemini with a structured JSON prompt. It suggests a real world intervention like increasing urban forest cover and returns an estimated cooling delta. That hypothetically cooler heat map
mitigation
is then
scenario,
rendered
implementing a
live on the
massive
Liquid
urban
Galaxy screen.
afforestation
So,
campaign
this
to
isn't
establish
just a
Miyawaki
visualization tool
microforests and green
anymore,
corridors
it's
across New Delhi's
actively
vacant lands and
giving
roadside
city planners
areas.
a data
This
backed
would reduce
what
the
if we
local
acted
temperature by
scenario
3.5
live on a
degrees
wall of
Celsius.
screens. And this isn't limited to India. Any city worldwide can be searched and visualized the same way, since City Lookup runs through OpenStreetMap nominating. So it fetches the story from the Gemini, and you can see that the heat map across San Francisco is rendered based on the real data available on the internet. So you can see that the heat map is rendered over San Francisco city. Thank you, Andrews, Mentor Siddharth, and the entire Liquid Galaxy team for this incredible opportunity. Thank you for watching.
Hi everyone, I am Aniket Dhingra from VIT Pune and this is Global Pulse, an AI-powered world intelligence map built during the Gemini SoC 2026 under the Liquid Galaxy organization. So Global Pulse is a Flutter-based Android controller app that transforms the Liquid Galaxy rig into a live global intelligence dashboard. It aggregates real-time data from NASA, USGS, and WHO and uses Google's Gemini AI to analyze, narrate, and visualize world events across multiple screens simultaneously. The idea was simple. What if you could walk to a LG rig and ask it in plain English what's happening in the world right now? So let me walk you through the code base of the app in brief. The app is built entirely in Flutter with Dart, following a clean MVVM architecture or the model view model architecture. The state management uses block, and services are injected via provider, and local storage uses Hive with manual type adapters, no build runner. The data pipeline has three data sources: NASA, USGS, and WHO, using DO with independent failure handling, so no single source can break the app. The LG integration runs over the SSH and SFTP via the Dart SSH2 package, sending KML files to the Google Earth and HTML overlays to the slave screens. All screen calculations are dynamic, so the app works on 3 screen, 5 screen, or 7 screen LG rigs without any code changes. Google Gemini 3.6 Flash powers all AI features through the native Gemini app. So let me walk you through the UI UX of the app. So this is the home screen of the app. This is the total active events shown, the number of earthquakes, disasters, and disease alerts. This is the daily global pulse AI feature, which generates a 60 seconds AI briefing. Then we have the severity breakdown, the top active regions, and the recent events. So when I click on the header image, it redirects to the map screen. So when the user is not sure what to do on the map screen, they can click on the I button, where all the information is provided for them to navigate to the map screen. Then we have some filters to filter out events. We have the mute and mute button for the Flutter TTS, and all the events are grouped into clusters. So when the user clicks on a cluster, they can hop onto the event, and then the event detail sheet is displayed, popped up, where they can also get the AI insight. Then we have the AI screen, where you can talk with the AI in natural plain language. Then we have the historical timeline screen, where there are filters and you can fetch historical events. Then we have the settings screen, where you can put in the LG rig details and connect to the rig. And if you want to have the AI features enabled, you need to have a Google AI Studio key. These are the data sources, the API status, the text-to-speech toggle on and off, and some LG quick commands. So let me give you a quick demo of the app on the rig. I have put in the LG rig details and connected to the rig, and as you can see, there is a logo displayed on the leftmost screen of the rig. Now I'll move on to the home screen to show you a demo of the Daily Global Pulse AI feature, which generates a briefing. So when I click on the play button, it generates a 60 second briefing of the past 24 hours event that happened. And inside the briefing, all the major event locations that have been specified, the rig flies to those locations. And also there is an overlay displayed on the rightmost screen of the rig, which summarizes all the global events that are happening right now around the globe. And when the briefing is finished, the Google Earth is set back to its original position. Now I'll move on to the map screen, where I can hover over a region and fly on. When I press on the fly to view on LG button, the LG flies to that location, and also an overlay appears on the rightmost screen, which gives you a summary of the region. For me, Gemini SoC was the most challenging and rewarding experience till now. Gemini SoC helped me think beyond just writing code. It helped me think about real-world deployment, user experience, user testing, user interface, and also product reliability. I want to thank my mentor Siddharth, and also Andrew sir, for guiding me at each step wherever I had a doubt or I was stuck during the development of the project. And I also want to thank the Liquid Galaxy Lab team, because this organization builds incredible things, and I am truly proud to have contributed to it. Thank you.
Everyone, and hello Liquid Galaxy team. My name is Amit Verma and this is my project AI Travel Itinerary Visualization System. The main goal of this project is combine the AI powered travel planning with the Liquid Galaxy. So I have first of all Liquid Galaxy connection module, and other side is destination weather and Liquid Galaxy connection. And so first of all I can enter the Liquid Galaxy master IP address and user SSH username and password, port, and the number of screen, and they are connected to Liquid Galaxy. And the second thing is to move the main travel planning flow. First, as you can user enter destination, I will choose Mumbai. So I will set the travel date, and I am using the GEO API for autocomplete when I tapping to the destination. So GEO API provide a location of these places, and I set the budget and travel person and generated the itinerary. After filling this, now I click generated itinerary. So this is where the AI part of the application come. I am using the Google Gemini, especially the Gemini module configured in the project to generate the travel itinerary. So applications and the destinations, coordinates, and travel duration, budget, travel, and as you can see coordinates and best time to visit, and highlight and address, and as you can see that, and Gemini send me the multiple places to visit in Mumbai. So I will tap to the view in Liquid Galaxy entire. As you can see, I have added two option, view in entire itinerary in Liquid Galaxy. So the all places are showing on Liquid Galaxy screen, as you can see that, and this is generated travel itinerary in screen. So I am also integrated the Liquid Galaxy logo. I will show that. And so to summarize the main technology used in the project, I will also view places in individually in Liquid Galaxy. So Flutter of the application is used, and GEO API use, and Google Gemini also use. And as you can see, I will tap to the Liquid Galaxy logo show. So the leftmost screen logo will be appear and also disappear. So basically that is my demo part, and as you can go to the project's implementation files. So as you can see that is my commands file, and fly to dart file, and orbit to dart file, and there are KML generators. So the KML is generated to this file, and there are my model directory and service directory. There are my main LG command service. So the backend of this project are handled in LG command service. There are my trip model dart, and there are my main itinerary screen dart. So the all functions and are calling in this directory, and there are my most important part of file is Gemini service. There are all APIs are containing on this file, and there are my weather service, as you can see that, and there are my trip planner, and this is my main data. So basically that is my demo of the Gemini Summer of Code. So thank you for watching, and I hope do you like my project. Thank you.
Hello everyone, myself Abhishek Chaudhary, and I am a BTech student interning on the Liquid Galaxy under their program called Gemini Summer of Code, and today I will be showcasing my app called LG Quick Rig, where the goal of the project is to make widgets to make ease of access for multiple codes inside Liquid Galaxy, which makes access to codes such as rebooting, relaunching, and etc. easier to access. So without further ado, the home screen has all of these quick actions. For example, rebooting, restarting, cleaning, KML testing. For now, let's just try out this KML testing button and see for ourselves how it works. As you can see, the test KML has been put on Taj Mahal and it has a red pin on it. Next, I wanted to show, let's just do clean KML and see whether it's working or not. As you can see, it is working. Next, let's go to the widgets. And here we have this connection monitor widget, which has these camera controls inside of it. We have the fly to, orbit, and overlay. So I wanted to showcase this overlay button because it has an feature to drop pins at any location you prefer, and also to drop images, whatever image you have on the map, as a KML also. And then I'll choose, I have this web image downloaded, so I'll pick that, done, and then one, and then hit enter. And as you can see, the image has been put on the LG rig, and that's all for our image overlay option. Now I also wanted to showcase the AI feature within the app. I need to have my API key and add it to my settings. So for that, I need to go to settings, and here I have this Gemini API key. I'll paste it here, put on a daily budget which I want to have for this for daily basis. 25 cents is a lot. So I'll hit save, and when it's done, we'll go to the rig, and we have this Gemini button here. And now I'll say something like go to Taj Mahal, so drop a red pin there. And as you can see, it has started working. And we have a red pin on Taj Mahal. So this AI not only helps with navigation, but also it has an option to help you with when you are in need and you need to fix rig or your current rig and have some error with the LG Quick Rig. So it can provide you with options on how you want to fix the LG Quick Rig, and everything is inside the code base already. Moving on, we have these options also inside the 4x or 1x4, where we have the clean, the relaunch, the reboot, and shutdown. I have already shown how the clean button works, and now let's just try out the reboot to see whether this widget works or not. As you can see, the Linux VM already is rebooting, and our application has been working perfectly fine. Moving forward, I'll be showcasing the Linux widgets. So for now, let's just test the KML and see whether it drops on Taj Mahal or not. As you can see, the testing KML has been dropped properly on the Taj Mahal. Next is try out clean KML, and for finally I'll just use something like reboot or shutdown rig. Let's do shutdown rig and see whether everything is working properly and fine or not. As you can see, the Linux VM has been shut down, and all of these functionalities, both within all the widgets, are working properly fine, both in application and the Linux VM.
Hello, my name is Chang Do, and this is my video about my final demo for my project for GSoC, Gemini SoC 2026, which is Red List Endangered Species Vietnam editions. So in this video, I'm gonna show you how it looks both on the phone and on the rig. So let's start. Now I'm gonna restart the applications, and as you can see here, this is my first splash screens, the second one, and once it is done, it's gonna be moved to the home screen where I can connect here. I click the connecting button, and the command's gonna be shown here, and once it is done, you can see in here the connectivity status gonna be changed, and we're gonna move to the map screens, and I'm gonna show you how it looks on the rigs. So here, this is a logo, and on the master screens we have the same maps display with the same marker as the red file here, and in here you can sort for the status of species, the group of them, or maybe the habitat, or you can search for the name of them also. So for example, we choose this one, so you hear the TTS voice is speaking. We can mute it as well, and also on the rigs here we can see this is the KML. So the KML is loading, and it's gonna be shown in some seconds. So yeah, as you can see here, this is the information about that species, and if you click on the history journey, it's gonna move to the history one to show different KMLs and also different TTS voice. Similarly for the looking ahead, yeah, so this one is for the outlook and actions, and we can do the same for any other species. And moreover, I have the tool screens here, so you can do a lot of things with this like the commands by clicking the button. For example, if we click on the clean logo here, and once it is done, you see there's no logo anymore. And if we click on the clean KML, when it's done, there's no KML. And also I want to show you, this is the chat one. So if you tell me more, you can ask anything about the applications or the species, and this one is connected and powered by Gemini AI, so it knows everything about the applications and the species listed in the applications. So you can ask them anything here, and it's gonna answer you in the real time. So we can end the chat here, and also we have like this one is the dark mode and the light mode for the whole screens. So you can choose whichever you want to see that better. And I will also want to show you like the code base. This is my code base that mainly I work here. I have the data, I have the models for the species, the provider like navbar and theme provider to be used along all the applications. Also I have the screens for different screen like chat screen, home screen, map screen, setting screens, splash screens, and everything. And also at the same time, I have very important is the services. This is the chat service that we can use everything here. So the prompts is here so that it can work on our applications, and the KMLs, everything relating to KML, Liquid Galaxy here, service, and also the species service where I send the command to Gemini and then get the answer to shown in the KML and also in the scripts, and also the widgets to use with the dark mode and the quick actions bar. So everything is here, and I'm gonna upload them to the GitHub. So if you want to see more, you can go to GitHub to see everything. And last but not least, I want to send my thanks to the whole team, especially our mentors, mentor Andrew and mentor Siddharth, who has directly guided us and gave a lot of advices. And also I want to thank the whole Liquid Galaxy team, people at the lab that have tested our applications and gave us the feedback. And I also want to thank very important to other contributors both in the GSoC and also in Gemini SoC, because they have inspired me a lot, and we have together built the applications. So thankful for this. I'm very glad, and thank you for listening and watching. Thank you. See you.
Hi everyone, I'm Tanish Sharma, a third year Electronics and Communication Engineering student at Punjab Engineering College, Chandigarh. My work on the Cyber Visualizer project at Liquid Galaxy as a Gemini SoC intern focused on building interactive visual interfaces for exploring cyber data, where I got to apply my skills in software development and visualization on real world datasets. I'm excited to share my work on the Cyber Visualizer application and what I learned along the way. So, this is the logo of my application, and the first screen will be the splash screen. So this is the splash screen. Next, this is the how the application looks like. If you're using the application for the first time, then it will also play an onboarding tool for you. Something like this. So this is how the onboarding tool looks like. Get started. So to fully utilize the potential of this application, you would need three API keys. One is the Honey Labs API key, one is the Abuse IPDB API key, and one is the Gemini API key. You can get all three of these for free and also upgrade for paid tiers as per your convenience. This is how the live attack feed screen looks like. These are the set of live attacks right now. We can update them. So let us try to project them onto the Liquid Galaxy rig. We go to other, visualize all. You can see the rig loading the KML. The point of observation is right now India. We can change the point of observation from here. So now we can see the attack vectors on the Liquid Galaxy. Let us zoom in a little. We can click on any of these lines and it will give us a detailed pop-up about that particular attack, like this. Now we can query Gemini AI model. So it has generated a detailed report regarding the attack. Now we can also use this report and the list of attacks to create a 3D tool. It says querying Gemini AI Threat Intelligence. The tool is ready. Let us click on Start Tool. And you can see the rig changing.
Our focus for this tour is Delhi, India, key target experiencing a range of other category attacks.
So this is the voice tool. There might be some audio delay due to the heavy workload that my laptop is handling right now. We can go forward and backward amongst the sequence of events. So threats from United Kingdom. Next we have threat from United States. If we play it, then it would load the required KML and then start the Flutter TTS service. So now moving on to the next screen, that is the historical database. So now moving on to the historical database screen, it has the list of all the fairly popular attacks since 2003. So we can filter these attacks based on these different types. Let us select 2020 with the sector as, let's say, finance, and we can find three attacks. So either we can query Gemini regarding these three attacks separately, or we can create a combined generate 3D tool. We can also query Gemini overall for all these three if we want to find some kind of common factor between all three attacks and relate them with each other. So let us try creating the 3D tool. Is prepared. Start tool.
Welcome to the 2020 Finance Sector Cyber Attack Tour.
Just pause it. Next, we can click on this particular attack and ask any specific thing about this. Let's say provide a detailed technical breakdown. So this will query the Gemini API with the data of this particular attack, and Gemini will reply accordingly. We can see the reply, and Flutter TTS is also enabled here. So let's increase the search filter by a little. Let's say, so this is the list of attacks from this IP. You can see this IP track analysis card, a total of 257 reports in past 5 days. And this is the domain, the ISP, the country is China, confidence is 100%. We can analyze the attacks with Gemini to find a particular pattern or to get some specific insight about the attacks. We can also create a 3D geography tool similar to the tool in the historical database and in the live attack feed. So now moving on to this is the attack simulator. We can describe the attack scenario here. Let us select one from the presets. We would force a such attack from China and Russia on a server in Germany. Simulate scenario. Projected successfully. So we can see. Let me quickly just disable the yes. So we can see the rig changing and the kernel files loading. I would like to sincerely thank the entire Liquid Galaxy team for giving me this incredible opportunity and for making this experience so valuable. A special thanks to the mentors Siddharth and Andrew for their constant guidance, support, and encouragement throughout the journey. I'm also really grateful to all my fellow contributors who helped me whenever I got stuck and made this experience so enjoyable. I've learned a lot both technically and personally, and I'm truly grateful to everyone who made this possible. Thank you.
To a world you can see through panoramic screens, living in the grand spatial dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid Galaxy, we see it all.